Today we're going to talk about alpha levels. Sometimes we need to make a decision about whether to reject the null hypothesis or not. It's not always an easy thing to decide that. Recall that the p-value is the probability that tells how surprised we would be to see the data if the null hypothesis is true. When the p-value is small, it tells us that our data is rare given the null hypothesis. And a lot of times, if it's very small, this causes suspicion. We ask, did it happen by chance? Is there really, some reason that it happened, or was it just random? So the question we ask is, how rare is rare? We would like to have a way to evaluate that to make a decision. We can define rare by setting a threshold for our p-value. When p falls below our threshold, we reject the null. When p falls above our threshold, we fail to reject the null. The threshold is called the alpha level. It is represented by the Greek letter alpha. It is also sometimes called the significance level. Common alpha levels are 0.1, 0.05, 0.01, and 0.001. And these are completely the statistician's choice. You decide which one of those you're going to use. Obviously, if you're testing the safety of, say, airbags, you want a pretty low alpha value. If you're just looking at something like, who prefers pizza with pepperoni as opposed to who prefers pizza without, then you wouldn't want an alpha level as high. The most common alpha level is 0.05. When we reject the null hypothesis at an alpha level of alpha, we say we reject the null hypothesis at the alpha level of significance. If we fail to reject the null hypothesis at an alpha level of alpha, we say the data failed to prove sufficient evidence to reject the null at the alpha level of significance. And we never say we accept it. We never say that we accept the null hypothesis. We only say we failed to reject it. And that's it.